What does effective, simple threat hunting look like in AWS? Well, let's find out from the Wiz team. I've got an awesome, cool article from a couple of the researchers at Wiz, Hilal Ramati and Gili Tikochinsky. I hope I got that right. They recently published this article about the threat hunting they did on IMDS. That threat hunting led them to discover exploits being used against various services. Now, I really love this article because of how simple and effective it is. And it shows if you have the right data and you take a simple approach, you can really have outsized results when it comes to threat hunting. So firstly, in the introduction, they go over what IMDS is. It's the Instance Metadata Service. It's designed to provide virtual machines with a simple way to get security, temporary credentials, and critical data without hard coding secrets. Over the years, threat actors and bug bounty hunters and everyone else in between has abused that service. The Instance Metadata Service is a server running on every cloud computing instance that provides temporary short-lived credentials. AWS uses it, GCP has a version of its own, etc. If you want to get some information out of this service, you just make a simple web request to it. In AWS, there are two versions of this service. V1 was a very simple version, which meant you could make a GET request to various endpoints on that service and get the information right back. But that, of course, made it susceptible to SSRF attacks, server-side request forgery attacks, where the attacker could coerce an application to go make that request and return them the details. You might remember the Capital One breach. That's the attack technique that was used in that breach. And so as this service was abused more and more by a variety of breaches, AWS implemented V2. V2 requires two different things that make it much harder to abuse. One is that you need to be able to make a put request as well as a GET. You also need to be able to send HTTP headers. It makes it less viable via SSRF, and in fact, you need another type of attack to do it. This article goes into the types of attacks that might use this technique. We've already covered SSRF. There's code injection or misconfigured workloads, and they say that applications with injection flaws or unnecessary network access can be manipulated to query IMDS internally, effectively turning the workload into a proxy for the attacker. And again, if the attacker can send arbitrary requests, a very simple GET request in terms of IMDS v1, or slightly more complicated request in terms of v2, then they can go and retrieve information, including credentials from that service. The cool part of the article starts here, which is how did they approach this threat hunting? Part of their monitoring is threat hunting for global anomalies, behaviors that stand out from normal activity across all cloud environments. Our initial threat hunting hypothesis concerning IMDS is that if a common application doesn't normally use IMDS and suddenly does so, it might indicate that the application is somehow being compromised by an attacker. So they got a bunch of data from their customers, presumably, about requests to IMDS. First, they needed to baseline normal IMDS usage. By analyzing telemetry from across environments, we can build a high confidence list of common or expected IMDS clients, things like the SDK and EC2 agents, etc. Then they need to identify the suspicious patterns or perhaps the infrequent access. Once we know what's normal, we look at what isn't. We search for processes that access IMDS in only a small fraction of environments, things that commonly exist in cloud environments but usually just never talk to IMDS. These are rare or one-off access patterns that often point to exploitation of SSRF or remote code execution vulnerabilities, or malicious code introduced via supply chain compromise. So the next thing they do is that they posit that there are certain parts of the IMDS service that are so infrequently used that they will stand out if they're being accessed. They call out 3 endpoints here, which provide important information that an attacker might want. For example, the IAM role assigned to the instance, or the list of IAM roles that the instance can assume, or perhaps a list of the service accounts that the compute instance has access to. Typically, these aren't accessed by regular processes. By filtering out all the baseline access that they know is common and safe, and by focusing on these endpoints that are useful to the attacker but rarely accessed by normal binaries, they can start to find interesting patterns. The following visualization shows our results after filtering out the dataset to exclude programs with 0% IMDS access or insufficient data, those appearing in only one environment. So they're looking for potential breaches across a number of environments. Then you can see that there are a variety of binaries that access that endpoint pretty commonly. For example, an mCloud setup. And then there are a bunch that are very infrequently ClickHouse. Turns out, using this technique, they found some pretty cool stuff. The first one was a Pandoc SSRF vulnerability. Using the process described above, we uncovered exploitation in the wild of previously unknown zero-day in a popular web service stemming from insecure use of Pando. The hunt began with a process named Pandoc, making an unusual IMDS request. While the binary can be found in numerous environments, in less than 2% of those environments, it was consistently accessing sensitive IMDS endpoints. So what we have is a binary that's used a lot, but only in a small percentage of environments, it's accessing that endpoint. They were initially unfamiliar with Pandoc, but a quick search showed that it was a Linux utility used for converting between markup formats. There was no indication in the documentation that it should be accessing credentials in the IMDS service. Their investigation led them to a GitHub issue reporting an SSRF vulnerability in Pandoc when converting from HTML to PDF. This would allow the attacker to craft an iframe that points to the IMDS service or other private resources. In this case, the web service using Pandoc failed to include the raw HTML flag or the sandbox flag when converting HTML documents, both of which are recommended in the documentation when handling HTML. The attacker submitted crafted HTML documents containing the iframe tag, elements whose source attributes targeted the internal IMDS service. The objective was to render that document and exfiltrate the sensitive data that it was requesting from the service. So the attack worked in the sense that the SSRF executed, the endpoint got hit, but because they were using IMDS v2 and couldn't craft the special headers or change the request type, it didn't work. But the research team at Wiz were able to identify this SSRF vulnerability, which was previously reported to that project. If you're enjoying this dramatic reading, I guarantee you'll love the weekly newsletter. So head on over to awssecuritydigest.com and we'll get it in your email inbox every week. The second finding, remember on that graph right at the very left side, there was ClickHouse? Sounds familiar? ClickHouse can be found in many cloud environments, but again, during our hunt, they found one case where the application had access to the instance metadata service. They did some research and looked at a blog post and found that ClickHouse's use of select star from URL SQL method can be abused when misconfigured if unauthenticated users are allowed to query arbitrary URLs. They expanded that research and found that it can be used to access the IMDS service and read sensitive data such as tokens and secrets provided to the machine. In this case, the instance was running in GCP, which of course means that the technique isn't just specific to AWS, but any cloud provider that has one of these IMDS services is potentially vulnerable. The attack was again unsuccessful due to some mitigations. The compromised instance simply lacked credentials with sufficient privileges to cause any damage. They point out that the attack could have been much more serious if there was other permissions possible. We'll skip all the corporate sales stuff, which you can look at yourself. For me, the main part of the conclusion is that from a threat hunting perspective, we believe that the key is to stop hunting for needles in a haystack and start looking for what shouldn't be in the haystack at all, which is a metaphor for what they've done in this blog post. And I think this is a really powerful technique that threat hunting teams can go ahead and use in their daily threat hunts, whether it be in IMDS, request data, or any kind of data. Take a baseline, then look for things that shouldn't be making certain types of calls or shouldn't exist in the data and go from there. They give a few TTPs at the end. They aren't exactly things you can plug in to your Splunk or whatever and just use, but they are interesting nonetheless. I hope you've learned something from this article, and I hope you have a go threat hunting for yourself. And if you like this article, please remember to like and subscribe.